Everyone, and welcome to the Information Bottleneck, the podcast that squeeze out the relevant information. I'm Ravid, and this is Ellen, and today we have a special guest. This is I am Ahmad Beirami, and he's an ex-researcher at Google. So thank you for coming.
Thank you so much for having me, Alan and Ravid. And hi, everyone.
Hey, so as always, let's start with some news and cool things that we heard this week. So, Ellen, you want to start with the NVIDIA OpenAI deal?
So a deal, I think that the numbers are in the $100 billion range. And of course, this is just one deal, but $100 billion range of OpenAI procuring a data center infrastructure, so mostly GPU compute from Oracle. And Moody's had an article that's kind of warning about so-called counterparty risk, this idea that one or the other of them might not be able to come up with that kind of money, or that the demand wouldn't materialize, and so this fears around like what the contract looks like. So I did a lot of I would say talking to Wall Street types recently about these kind of concerns, so a lot of it has people thinking that there might be like frothiness or bubble dynamics right now. So what do you guys think?
Yeah, so I don't know, like we talked about it a lot, right? Like every once in a while, like you have a new deal that just move money from OpenAI to Oracle, or like from Oracle to NVIDIA. But at the end, it looks that everyone are just spending a lot of money, and the only company that actually make money out of it is NVIDIA, right? So this is like the bottom line. And again, it depends on, I don't know, it's quite fake money in the sense that like OpenAI just buy new GPUs from NVIDIA. So it's not clear to me like why it's so important, this deal.
Yeah, I think likewise. I can't really comment on the kind of the economics of the deal, but what's clear is that NVIDIA is selling GPUs and selling them fast. And I think that seems to be still accelerating.
Yeah, it looks like we have new labs and new startups that need GPUs all the time. By the way, did you see the recent? I think they call periodical labs. Did you see it? A lab they just announced yesterday. They want to merge experiment or like physical simulations with AI. There are a bunch of ex OpenAI and then Meta and DeepMind folks that are trying to, like, they raised, I think, $300 million, huge amount of money, and they are trying to actually build, material science and to try to integrate AI with more things that they say, like things that related to atoms, not to bits. I must say that, like, personally, I really like this direction. I think we have so many startups, like so many labs these days that are trying to do some incremental improvement in some use case that it's not clear if they are important or not. And here they are trying to do something very, like, I don't know, like it looks very important, and it looks very like it will require a lot of research and a lot of product development. So we will see. It's very ambitious.
Yeah, I think it is. I think what I would add is that as the models are becoming more capable and the horizon of the tasks that they can autonomously kind of handle, then we will see a lot more use cases unlocked. And as these use cases get unlocked, there will be need for more compute. So I am not seeing kind of the need for compute decelerating anytime soon.
Yeah, I think agents in particular are a token black hole, basically, of demand, right? And I think that one place that we don't compare models too much or against each other. I saw somebody ranting and raving about this in a comment on Hacker News. So if they're listening, and remember that themselves writing that, shouting them out. But yeah, we don't compare ChatGPT versus Claude versus Gemini based on token efficiency in the benchmarks to get to an answer. And so it could be that one of these models is slightly better than the other, but if it's spending like half as many tokens on average, certain customers will find that extremely compelling.
And I think like at the end, you would say something?
No, go ahead. I will go after you.
Yeah, so and I think like at the end, like when we will have like agents that that are making like there was this new feature of OpenAI, right? That like you have an agent that can search over the internet and buy by himself like whatever you want and things like that. It will be a huge problem. Right, like now your agent would just travel all the time and like search over the internet over time, and you need somehow to restrict it. It will not eat all the GPUs that are available. Probably the like startups will be like startups that try to make efficient models will be much more popular. Yeah.
No, absolutely. And I think to add to that, I think in terms of efficiency, there are two dimensions. One is latency and one is compute overall. And then you have to contrast that with performance. And I think we really have been doing a very poor job capturing latency and basically compute.
Yeah. Do you think that we can have like, I don't know, small models that are really good and has like really that they are really efficient and they don't have any disadvantages for specific task?
So I think that's a great question. I think in the end of the day, like we are information theorists and we tend to believe that there is going to be a limit in how much capabilities we're going to be able to cram into a 7 billion parameter model. So are we close to those limits? I don't know. But I think at the very least, with the current way of training models, with basically our current practices, etc., there seems to be a gap between a 7 billion parameter model and a 50 billion parameter model in terms of capabilities. And we've been trying all sorts of distillation, pruning, whatever kind of way of, okay, getting all those capabilities from the 50 billion parameter model back into the 7B. And there seems to be that there is no free lunch. We end up losing something. So I don't know if we are close to the limits. Maybe we are not. Maybe we will be able to push them further. But I think that at some point there will be some limit. What that limit is, I don't know.
And I'll point out that in some ways, quantization, which is an increasingly popular technique, also harms or is getting at the heart of trying to figure out what is the minimum amount of bytes of information in order to represent a concept. And we're already seeing, that for a while there, it was regarded that quantized models were basically free in their impact on models, but I've been seeing some comparisons that have compared specifically LLM inference engine providers, like GPU per token LLM inference providers such as Fireworks AI, Together AI, Base 10 and others, and Base 10 in particular has very bad log probs and matching. So they're using some extremely hardcore quantization or other techniques which are leading to their models not preserving the capabilities of the main ones. And so I don't know, I'm just bringing all this up because when we start trying to get an answer to the question of, what is the theoretical limit, I think that in a lot of cases, the fact that we're able to so quickly start hitting those diminishing returns tells us that for small models, I do think that at like 1.5 quants that we really are at that threshold of like minimum number of bits.
But the question is like at the end, I don't know, if you're a startup, you have like, I don't know, 20 tasks that you need to solve. Like, I don't know, most of the use cases, like you have some number of tasks that you need to solve, and you don't need, a general purpose model that can solve everything and like it knows math and knows, like, I don't know, some other task or thing like that. Like, you have very specific set of tasks that you want to solve, and probably you don't need the huge amount of parameters, and you can call it distill, you can call it like whatever you want, but you can use it.
So I think that's right. But the issue is that, let's say you have some evals that capture the tasks that you care about. And then you're like, okay, let me actually try to just fine tune my model on these tasks. Maybe let me actually distill the capabilities of models on these tasks and so on. And then you succeed. It's like, okay, I am getting maybe only 0.5% drop, or maybe not even any drop on those tasks. But I think there is going to be generalization issues, because in order to solve those tasks, there are other implicit capabilities that you're relying on, like instruction following, like reasoning, and so on and so forth. And the benchmark that you have doesn't capture those explicitly. It just basically captures those on the data set that you have. And then there is going to be some generalization loss on those core capabilities that are key to solving the task. And then eventually you will see that the model is on basically, when you try to deploy it, there is going to be some performance loss.
Yeah, I agree. I think, like, and then it depends on how specific your task is versus how, like, general you want to go. Um, I believe that most of the startups, like, at least some of them, can go with very specific set of tasks. But you're right. Like, if you
Yeah.
want to solve something general, uh,
Yeah, but
it will be hard.
basically, if they can try to get verifiers for their tasks and then try to do some sort of RL fine tuning, I think there is better hope for generalization than some sort of supervised fine tuning of the models or supervised distillation.
Why I think so? Like, okay, let's let's start with you have, like, several papers about it, and that how
So,
it's related. But yeah, tell us.
yeah, I think this one first, I will start with a paper that's not mine called RL's Razor from researchers at MIT. And basically, what they show is the following: they show that when you do fine tuning with an RL objective form, with a verifier, there is a lot more generalization. So they empirically show that on a variety of tasks. They also prove theoretically that when you do this kind of RL fine tuning with a 0-1 loss, what happens is that you're going to get an implicit KL regularization, basically between the new model and the old model. And that may sound like, okay, who cares about KL regularization? But then in a previous work last year, we had shown that when you're doing KL regularized fine tuning, that is theoretically equivalent to multitasking between the tasks that went into the kind of pre-trained checkpoint that you're fine tuning from and the new task that you're fine tuning for. So in a sense, if you're a startup and you're trying to fine tune a small model, and like maybe you're actually distilling a small model from a larger, like more capable model, then actually that multitasking is important, because now you're multitasking on some of these key tasks like reasoning, like instruction following, that went into the training data of the checkpoint you're fine tuning from. So I think that is going to have basically more chance of succeeding in a way that then you're going to get a capable model that can accomplish the tasks you want.
But at the end, so, I don't know, like, RL, like, it behaves really weird, right? Like, we don't really understand, like, in this context, RL, right? Like, there are all these works that show that you can train with random verifiers, right? Or, like, you can have, like,
Mhm.
train with one one example, and then people looked on the entropy of and what is happening to the entropy in RL, and they found really weird things that like it looks that this weird tweak that we are doing, like using GPRO, like make it like we don't really understand what is happening there. So do you think it's
So yeah, I think the RL that we're doing today is not really RL. We are actually
right?
using
Exactly.
RL as a distillation tool, right? So, and we are really piggybacking on RL infrastructure for online rollouts to do distillation, right? That's pretty much what we're doing. And that's why that KL regularization is important, because when we're doing distillation, we want to distill the capabilities that existed in the checkpoint we're distilling from. Now, maybe we also want to learn a couple new capabilities or like a new task and then combine all the capabilities and put them into a new model. And distillation doesn't necessarily mean that we're distilling into a smaller model. Maybe we're distilling into a similar sized model, right? So that's kind of what happens with RL. And I think some of those artifacts that you mentioned are due to the fact that we don't look at our data enough to be able to capture the patterns. It's like, okay, if I'm seeing 5% gain, where is it coming from? Am I like doing better pattern matching? Is my eval is actually capturing what I care about, and so on and so forth? And I think some of that was maybe attributable to not digging deep enough into what's happening.
Yeah, I think like evaluation, I don't know, in LLMs, it's just terrible. We had a paper a few months ago that we looked on hallucinations. And we have this idea that like you can look on, it's called metrics-based entropy. Basically, like you look on the eigenvalues and distribution of the eigenvalues and making some, you look on it as like probabilities, and then you look on these entropy, how they distributed. And we looked on it in different settings, and we found different things across the layer and things like that. And then we had this idea that maybe we can detect hallucination with it. And we tested it, and it worked quite well, much better than other baselines. But the problem then, at some point, we found that it just correlated with the length of the answer. And it's just like not working. But the problem when you normalize, or when making like LLM as a judge, for example, but the problem is that also all the other methods for hallucination just make the same, like they had the same problem. They just feed it to how we evaluate hallucinations, and because this is correlated with length, like all these methods just almost didn't help. Um, in order like to, when you want to deal with hallucination. And this is again like and hallucination, right? This is something that everyone are trying to solve. Like so many people, so many labs in the last 2 years, right? Look on this problem, and no one said like, oh, we have a problem in how we evaluate our methods, right? So I think, yeah, and it happens all the time. I think this is huge problem. It's very hard to replicate, right? Existing
So
studies. Yeah.
I think you have a very good point here. And I think the point is that as a community, rather than focusing on beating all baselines by 3% and getting a bold number in a table and publishing a paper, we should actually focus on digging deeper, going and analyzing what is happening, where the gains are coming from, what are the actual pros and cons of different methods, and so on. I think as we are the reviewers, right? As reviewers, we should also ask for this kind of analysis rather than being
Yeah.
state of the art method. Like being a state of the art method is very boring. I see a lot of papers that claim they're state of the art. I look at the algorithms, I don't understand what's going on. And it's like, okay, where did you get the gains from? Like there is no
Yeah.
analysis whatsoever. There is some ablation studies, but it's not nearly enough. I think rather than publishing a paper in a month, we're better off if we actually go deep, engage with it, try to understand all of its limitations and be upfront with it. I think that's kind of the perspective we should take as a community, in my opinion.
Yeah, I agree. I think the main problem is that like people or like the community doesn't really care about analysis, right? Most of the time, it will be much harder to publish something like that. You just analyze methods and you're just trying to understand their pros and cons, and you don't have something like new idea that is state of the art. These kind of works, I really like them. By the way, I really like to do things like that, and they are so important. Like I know, like maybe the most cited paper that I have just make this comparison between different methods and claim that
Yeah.
all of them are wrong. But people, most of the time, people think that they are not publishable.
Those are the papers I actually love as well. It's like you learn something new from them. You learn a new insight, right? So it's like, okay, you are giving me a method that's state of the art. Like, if I'm not really learning anything generalizable from that, then that's like memorization.
Yeah. No, I agree. And I think specifically in RL, I think we need much better evaluation because we don't know, like there are so many tricks and it's so hard to understand like what are the actual benefits and when it helps and when it doesn't help.
Do you think that the stuff on world models and simulations that we've been seeing will be help with evaluation? So like doing reinforcement learning on synthetic like agent performance data and complicated simulations? Because I've seen that as a research direction from RL and agents general.
So I think basically we're just not even there in evaluating as models like LLMs. Like people choose different temperatures, different prompt templates, a lot of different things that they don't even talk about. And then every single one of these decisions is creating a confound. And there is so many of these confounds that are not even reported. And then you get some numbers, and then these numbers, you're like, okay, these guys said this other number, and I have this other number, and mine is 3% better. And you leave it at that without really trying to go into the details of like what is going on, like why this number is higher, what are the confounds, what are the similarities and differences, and so on and so forth.
Yeah,
Now
we
with
just talk
what
about No, we just talk about it like me and Ellen before that we have like if you just switch the so for example you're doing like a MIMPI or something like that, and so if you first scale the temperature and then do the sampling or do the other way around, it change your results. And it's crazy because different frameworks are doing it differently and no one care about it. Like it's just, yeah, we're doing it like that. But so we put it in the document somewhere in page 205 in the middle. And it's totally changed the results. And like, it's really hard to replicate. We had like actually a problem to replicate some of the results because this is how we found it.
Yeah, yeah, it's a profound issue with the field. And then when you look at all the stuff with conferences, right? I think the ICLR conference, this new one, has something like 3x or something the number of submissions as before. Now, of course, it's because it's being, I think, held in China or something, and so it's a very friendly place for a country that normally has to deal with serious visa issues. But regardless, the explosive growth of the people writing papers and thus the submissions to these conferences is probably a significant part of why, some of the things you really mentioned are happening.
Yeah, so I think, yeah, we are regularly now clearing like 25K submissions to these conferences, which I find like extremely excessive. And I wouldn't even be able to imagine how the program chairs are handling these papers, because believe it or not, the program chairs generally look at the papers and the decisions and everything in an Excel sheet. And yeah, how like scrolling 25,000 papers is just going to take a long time. But also, I think ICLR, kudos to ICLR for being open. At the very least, they like everything happens in the open, which discourages a lot of bad players from submitting, cutting like one idea into like three pieces, submitting like three concurrent papers, or a lot of the other issues that may happen in the open. So I think that this is discouraging a lot of that. Also discourages authors from submitting half-baked papers.
Yeah, this is also what I thought, but then ICLR, like iClear deadline was last week, and I thought that people like my collaborators, some of them, will not we will not, because it's published, so they will prepare it like in advance and like will not wait to the last minute to do, and like will shift the whole paper in the last 4 hours. But no, it didn't help. And there is the submission deadline is like 8 a.m. Eastern time, and people still like submitted like in 8:15. After the last minute, people still submitted the thing and changed the whole paper in the last hours.
Yeah, like I really want to be done with kind of this last minute thing. I remember in graduate school, I was collaborating with a group mate, and they submitted the paper 2 minutes before the deadline. And then they messaged me and they're like, okay, I put in the first version. Now we can iterate over it. And I'm like, iterate over what? Is like the deadline is in 1 minute. But seriously, I think the better papers that I've written, generally I have finished the writing 2 months in advance. Just post the paper on archive, let it be, come back to it, read it with fresh eyes, realize that the story is lacking in some ways, or you find new ways of telling the story, and then you revise it and so on. And even you revise it based on feedback. The other issue is that once people get their paper accepted, they have zero incentive to make any changes. I think that is actually the time to reflect, get all the reviewer feedback, just make sure that like all the bits and pieces are there, because that's only the beginning. It's not like the end. It's now you want to make sure that the paper is understandable by the community and so on and so forth. But unfortunately, nobody has the incentive. Everybody has already moved on to the next paper.
Yeah, I see a lot of the dynamics you talk about. And actually, I'm similarly with you. Even when I was in college, I did not like procrastinating. I certainly have turned in not great work, but it wasn't because it was 5 minutes before it was due. And I do see a strong culture of people doing the 5 minutes before thing with submissions. And I'll even admonish NeurIPS just a tiny bit here, because NeurIPS took some of us, such as a creative AI track, and didn't tell us if our paper had been accepted until after the ICLR review deadline. And so a lot of people probably who did not anticipate that might happen were forced rather quickly to resubmit to ICLR under not great circumstances. And maybe the response is, oh, well, these conferences don't have to cater to another conference's deadline, to which my response is, wait a moment, I thought we were in agreement that this was a cycle kind of thing, to which ARR, at least in the world of ARR, they do have to actually meet their deadlines for the next one, right? And so I don't know. Maybe this stuff is just the grumbling that happens every few months after conferences, because nothing ever changes right after the grumbling. Just for the record, and you are right, by the way. ICLR's openness is awesome. I agree.
Yeah. Okay, I want to talk again. Let's go back to RL, and maybe we'll start like so. I don't know if you heard. So Richard Sutton, the father of RL, just said that RL, that he thinks that RL that LLMs are a dead end. What do you think?
So I think we've been hearing different variants of LLMs are a dead end for a while. So maybe they are a dead end in the sense that they were not going to get us to super intelligence. But I think LLMs are today good enough in terms of capabilities to have huge impact. And I think that's like what I actually care about. And it doesn't mean that LLM is going to solve your problem in whatever context you have in industry. So maybe you have a problem, but I think LLMs are very useful primitives to bring into your workflow and be able to solve problems more effectively with them. I think we are going to see that there is going to be huge ROI on using LLMs in a lot of workflows. Uh, I believe that we will need at least one more scientific leap to get to the super intelligence. To be honest, I don't see how we're going to get to super intelligence with the way we're training LLMs today.
And what do you think will be the solution?
I don't know, right? So today, basically, what we're doing is that we are trying to get the brightest of humans in every discipline to generate and curate data for LLMs, and then we're consuming those data. Now we're starting to, with oral environments, there is like different companies trying to capture like the environments that represent different basically enterprise environments and so on to curate again data of that sort and feed it to LLMs. But so I think the LLMs are getting to top reasoning capabilities in many cases, maybe on par with top humans. And so if you think about it now, they're going to be maybe better than average human in many cases and so on. But are we going to get to super intelligence, however you want to define it? I think we need a new paradigm. And what that paradigm is going to look like, I don't know what that is. Basically, we need to be able to have verifiers, even if we want to do RL. RL
Yeah.
is based on verifiers. Where are we going to get the superhuman verifiers, right?
Yeah.
Yeah. Oh, go ahead.
So I think like one of the main argument against the current LLM is like that, right? Like all the dynamic exploration thing that like today it's not possible, right? Like we have the training and we have like it can be the RL or the post training, but we don't have this dynamic acquisition of data that we are walking in the world or like exploring like areas, and then we can say, okay, so let's go to this area and let's try to acquire more samples from this or more samples from there, and in that way like to extend our knowledge or extend the example that we actually use for training. Do you think it will be something that require for next stage?
So I think there are, like, you're bringing up two interrelated very good points. One is that the kind of sample complexity is like, okay, how many samples do we need to see to be able to learn? And I think in terms of sample complexity, whatever we have is very, very poor. And the other piece is that how much can we learn, right? In the end of the day, if you're training a 7B model, then it comes back to the fundamental limits of, okay, there is fundamentally so much we can basically put into this model. And now if we are like trying to do better at reasoning, maybe we are going to lose on the multilinguality of the models and so on and so forth. So how are we going to make those kinds of decisions? I think is going to be an interesting piece as well. But I believe you're going to have to, and we will probably make improvements in terms of the sample complexity, especially with RL. Basically, we're getting very sparse feedback. On the other end, we have supervised fine-tuning, which gives extremely dense feedback on every token. And I think we need to break that, and we learn like intermediary ways of learning that can get more effective feedback than sparse RL feedback, but don't kind of over optimize like the way supervised tuning does.
It's funny you mention that because our anti-slot paper has something kind of like that called first token prediction optimization (FTPO). But I just want to go back to the question that spurred all this. This is a very interesting discussion. I strongly agree with the idea of like needing superhuman rewards in some way, which a lot of times I think superhuman rewards can be things like automated theorem provers, computer algebra
Yeah,
systems, things like that.
yeah.
But ultimately, I've been hearing people using this Twitter exchange between Gary Marcus and Richard Sutton to argue that Richard Sutton is no longer a believer in the bitter lesson and is certainly not AGI pilled. Now, maybe, no, first of all, look, I don't care. Even if Richard Sutton, even if we lose him, I don't care what anybody says. Gary Marcus is dangerously close to grifter territory. He's ultimately not an AI researcher, and a lot of his arguments are clearly made without the kind of understanding of where the field is. But second of all, Rich Sutton, he's what, how old is he now? And beyond that, a lot of why he's claiming these things is, again, not saying that the bitter lesson is wrong or that the fundamentals of AI advancement are no longer based on more compute on more data, but rather exactly what you guys said, that text alone as a modality and maybe even autoregressive next token prediction might not be enough. I'm
So
even willing, I'll just finish by saying I'm even willing to defend the idea that LLMs, or certainly multimodality mixed with autoregressive, I think that and like tool use is probably enough to get to what we call ASI. I believe that.
maybe I can just say that my understanding is that Gary Marcus is saying we are not basically using humans enough in LLMs. And I think maybe my understanding of Rich Sutton's criticism was that we're using humans too much in LLMs, and that's why we're not going to get to where we need to go.
Yeah, I mean, what you're talking about with data set labeling makes a lot of sense. And this is an intricacy around, his argument being that you need to ultimately get out of the way. But in order to start, I mean, if we just got out of the way forever, right? I mean, we wouldn't have any of this stuff. Like, you need heuristics, you need trickery and things like that. And even that's some of what the DeepSeek R1 paper was trying to show, was creating large, synthetic data sets from very small amounts of seed data, for example, and then being able to bootstrap the whole RLHF process from that, or sorry, RLAIF, right? So I ultimately, though, I do think that we can devise ways to throw more compute towards getting better at verifying things. I even think like chain of thought as an example, or other strategies like that, spending more tokens correlating with more answers, implies to me that we just need to be clever, right? And even the fact that like deep research is so good when you just chain LLM prompts on top of each other like 200 times with grounding, their rate of hallucination clearly is significantly lower. Like, I'm willing to die on the hill that deep research is pretty, like, tells the truth much more than it hallucinates, and quite a bit more than any of the best models on the market without that complicated agent workflow do. So this is my argument for like, yeah, we need humans to like do good engineering work and maybe a little bit of good quality labeling to start, but eventually we can let the self-improving machine
So,
do the work, which is ultimately with Rich Sutton's thesis.
so in a sense, maybe let's do an analogy to having basically training a PhD student, right? So if you're training a PhD student, in the very beginning, you need to do a lot of handholding. And then as the student is growing, then you're going to have to delegate more and more to the student. And at some point, they're going to become autonomous and hopefully become smarter than you are, right? And do better. And that's basically the whole premise of training PhD students. So I think we need to maybe figure out that process. It's like, okay, how are we going to do that? But then we need to do it in a safe manner as well, in the sense that how are we going to make sure that whatever we're doing is safe and secure and cannot be really manipulated by bad actors, because bad actors are Like I was hearing about all the creative ways that people are now manipulating the conferences, and a lot of them wouldn't even come to my mind. It's like, okay, this is something that one can
Like
do,
what?
and like I'm not going to repeat them. I think this was a
Give us
conversation.
example, like anonymous example.
Like people are basically impersonating other people on open review platform and then trying to actually review their own papers as if they're other people and so on.
Oh my God.
And they're impersonating other people in actually believable manners. They have institutional emails that represents the institution that those people are from. I'm not going to tell you how they reach that point, but it's basically like this is something that wouldn't have even occurred to me to think about. So I think we need also superhuman ways of thinking about safety and security as well as we are growing these models.
So quick other fun anecdote of shenanigans that, again, I'm going to be fully anonymous as to who I know that did this, partly because I think it's so beautiful that
Why?
I wouldn't, no, I'm not tattletaling. Well, I'm about to give a different scenario, right?
No one is listening. You can tell.
No, I don't even remember their name anyway. But first of all, I noticed it because their poster said International Conference of Lazy Reviewers. And then I discovered after talking to this individual that not only had they not been accepted to the conference, but they also didn't pay to be there and had printed their badge basically based on the template that everybody's made. So they had like a bootleg badge, and they just found a spot to put their poster that was like not taken and showed their poster even though it got rejected anyway, because they're like, screw you reviewers, my work is good, I'm going to show it off. To which I don't know, I just think this is glorious, right? I know that like people, real academics who like, I publish too, but I think like not being not a professor, I think I have a little bit less of my earning potential and all these things kind of on the line from the slight debasement of this. But I just think it's glorious that it took this long and like only one person in a field of thousands or tens of thousands is doing this kind of stuff, right? But yeah, there are definitely conference shenanigans, and I'm wondering about how much more that we have no idea about. That again, like you said, I had because that trick also hadn't occurred to me, really, right?
So I can tell you this, like there is plagiarism, self-plagiarism, there is collusion rings, etc. We hear about them. I think these are real problems. Like they're more prevalent than we would think. They're actual real problems. So, and they make the entire experience worse for everybody because last year, some of these conferences got rid of bidding or created reverse bidding. And then you may get papers that you're not excited about or papers that are not necessarily in your domain of expertise. So, which means that you're going to do a poorer job in terms of reviewing those papers. But then this is they're trying to solve another problem. So, like, I think, again, like always, there is a safety, helpfulness trade-off here. And I think the program chairs haven't really figured out how to navigate those trade-offs in an effective way.
Yeah, I agree. But I think like in computer science, in machine learning specifically, I think the situation is better because you have so many people that try to reproduce and like to use these methods and these papers. So I think like, of course, not all the papers, but a lot of papers are verified by other peoples. And like if a method is good, so probably like a lot of other people will try it and will validate again, not maybe not the exact result that they published, but they will try it in different domains on different problems. I think if you compare it to, I don't know, to other fields that like you publish something and if you go and pass the reviewer, so then that's it. Like probably no one will look on your results and
Yeah.
your method, and it can be totally wrong.
Yeah, I think I totally agree with you that basically in the end of the day, what matters is the kind of community's reception to the work. I think that matters the most. And I think that label that accepted to NeurIPS is becoming less and less meaningful. I think even a decade ago, a good paper basically had 50% chance of acceptance, whereas coin flip would have been 25%, just if papers got randomly accepted, right? I think with whatever has been happening in the past decade, that 50% is going down towards the 25%. I don't know where we are today, but I wouldn't be surprised if we are at somewhere like 33%.
I think it also depends on the paper itself. Good papers will get accepted most of the time. Like, the best papers will get in, and the worst papers will stay like out. But all the intermediate papers, right, like you have like kind of 70-60% of the papers, like it will
Are
be
borderline.
almost like
Yeah.
a coin flip.
Yeah.
Yeah, and I was just going to say, having, I do try to go through proceedings, at least little bits of them on a pretty regular basis. I don't see a whole lot of stuff where I think like outright lies are there most of the time, or even just straight up bad science. I do see a lot of very marginal contributions, right? And I think that the real issue is like the idea of, it's not that this is a bad paper, bad science, but why is this here at supposedly the most prestigious conference in the main proceedings? And now, you're actually seeing the people that really want the prestige just going straight up to Nature and skipping NeurIPS, right?
So let's not get into the Nature debate, but I think, no, I've seen a lot of bad science in ICMLs and NeurIPS and iClears of the world. These are papers that I have felt that should have been clearly rejected. Like they're not even in the borderline bucket. And I think about a decade ago, the program chairs of NeurIPS did an experiment, which was really interesting. They asked the senior area chairs to reject the bottom 5% of the papers in their stacks without sending them for review. It was like a senior area chair looks at the papers, they're like, okay, this paper is clearly not NeurIPS quality, and they rejected it. Then they took about 100 of those papers and sent them for review. And out of those 100, basically gave them to other senior area chairs. And then through those senior area chairs, they got assigned area chairs, and those papers went for review. 6 of them got accepted.
Yeah, that's pretty bad.
Right? So it's basically that's the level of noisiness in the decision making that we have. So I'm not sure how we're going to be able to solve this. And this is about a decade ago. And things have been just getting worse and worse over the years.
Agree. I also would claim that most of the papers, like it's like a bad science. It may be that like they have good method, but at the end, people in machine learning and AI don't know how to make rigorous claims about like statistics and what does it mean to make a claim and how you actually need to prove a claim, right? Like, I know error bars. What does it mean? You have error bars. That's nice. Like now, so 5 years ago, like we haven't, like modern papers didn't have error bars, but now they have. But what does it mean? What are the error bars are?
I think a very common one is causal claims where what you're measuring is actually correlation, right? So I think that commonly happens.
Yeah. And because like I think the field is, so it's not like biology, right? That like the let's say the network or like the model is fixed and you just need to understand it and like to try to different the environment to make some changes. Here you can play with everything, so it's not clear what you actually claim, and when you play with something, what is the effect on other factors and things like that. So it's much harder. I don't say that it's not harder, but right now we don't even talk about it, and like we don't even talk about if like we claim valid claims. Yeah. Anyway, so just to summarize, I just saw a really nice meme on Twitter from Lucas Bayer that showed that like there is like a path for everyone that is getting older, so you can become a Gary Marcus or like Jan LeCun
Yeah,
that
I saw that.
don't believe in LLMs. You can become Jeff Hinton or a Benjo that think that LLMs will take over the world, or you can become a Schmidhuber that claim that
Yeah.
everything is belong to him and he all the models in the world.
I'll just one quick thing is the very first technique and something in 2017, the very first technique that I thought cool enough that I saw in some random AI paper that I was going to try to implement it from scratch myself was called cooperative coevolution. And it just happens to be a Schmidhuber paper, just for the record. And it was from like 2010. And I didn't know who Schmidhuber was or anything, but his name really is everywhere on a lot of techniques that did anticipate. So I think, like, the more I looked into it, the more I was like, okay, he's a little bit justified.
And it's a good question, right?
Yeah.
Like, what does it mean, like novel method versus like who like for sure, like all the methods are building on the top of each other. So it's not clear like when you need to claim that this method is like the first one,
Yeah.
right?
Yeah. And a lot of times it's just basically a lot of people simultaneously reach similar conclusions because you are exposed to similar inputs. And in some ways, we are like our minds don't operate too differently from each other. So then people will find similar things and like many things get rediscovered many, many times. Otherwise, we wouldn't be able to graduate.
Yeah. Yeah.
Yeah, but I think Schmidhuber is basically so he has made a lot of contributions, and I think he deserves credit for those.
Yeah, I agree. Okay, yeah. So we almost finished, but I want to ask you like several more questions. You work a lot on, let's say, the intersection between theory and practice, right? Like DeepMind, you published theoretical guarantees on some alignment policies and also make it work in LLMs. What is your take about this intersection? Because it looks that in recent years, you have a huge shift, right? People are making like very theoretical work about toy models and very practical work about real products, and you almost don't have an intersection between the two. What is your
So
take?
so to me, the theoretical work that's not grounded in practice, I'm not interested in that kind of theory anymore. Maybe I did a bunch of that during my PhD, but I don't think I have the time and bandwidth, and even I don't find it interesting to work on theory that has nothing to do with practice. And on the other end of the spectrum, I'm not also interested in just empirical methods that are just purely based on random exploration. So I'm more interested in guided exploration in the empirical methods. It's like, so, and theory can help shape the guidance of, okay, where are you more likely to find the right type of solutions? And then I think the best way is to basically go back and forth between these two ends and try to do some theory. It doesn't have to be like proving Rademacher complexity bounds, but like the theory, it could be like a statistical physics type theory that is going to give you some insights on how to design the algorithms, and then do some empirical analysis and then go back and like develop the theory and so on and so forth. I can tell you the story of the theoretical guarantees on best event paper. Actually, that's an interesting one. So when we were doing control decoding, this back in 2022, so control decoding was basically an alignment method, and we were trying to comparing with all the RLHF methods. Control decoding was a test time method. We were comparing them with training time methods. And then I was thinking, okay, let's actually throw a stupid baseline in the mix, best of n. And we want to beat that at least, and just to make sure that we are implementing everything correctly. So we compare with best of n, and of course we don't even reach best of n, and like best of n is better by miles. And I'm like, okay, what's going on? Redo the calculations. No, let's debug. No, then started asking other people and to implement best of n. And basically this happened like 5 or 6 or 7 times. I'm checking everything. Everything seems correct. Then other people, there is a bunch of reproductions that best of n is better than anything else that other people have as well. And only then I'm like, okay, why is best of n so good? Let's think about that. Like it's a good kind of theoretical problem. Obviously, I didn't have the bandwidth and time to think about it during the weekdays, but that became like my Sunday project of going through this rabbit hole of figuring out why is this so good.
Yeah, I agree. I think like the direction that you said, right? That like you first make some observations and then try to figure it out like the theoretical solution or like the theoretical proofs, and then you go back and check, oh, like now I have good predictions. Let's try to validate them. I think it's good flow. And the problem is that these days it looks that a lot of times people are making some empirical results and then they just wrap it up with some math, right? That it will look impressive. But I think in general it's really hard, I must say. So I did my PhD on information theory. I solved some equations, and I did also like on like statistical mechanics, spin glasses, things like that. And during the years, I shift to do very empirical works, because at the end it's really hard. It's really hard to combine it, and it's really hard to say, okay, I will prove something, and it will be very rigorous, and then I will take it and use it in practice.
Yeah. Yeah, no, I think again, as you're mentioning, I think it has to go hand in hand. And I think, let me just say one thing. I think a lot of these inject something that looks like a theorem into a paper to get it accepted. These are all reward hacking, right? So, and I think also the other piece is that people don't get the time to do the like thorough exploration, because you're just submitting 5 papers to each conference and then moving on. So you don't get time to think. Like, just slowing down is going to also give people time back to be able to explore, go deep, and then write one good paper. I think one good paper is worth more than 10 mediocre papers, and definitely worth more than any number of bad papers.
But do you think, like in the future, if people will put more time, like we can have some rigorous theorem about real world models that actually
So
work in practice?
So it will take time, right? So think about deep learning. I think back in 2015, nobody had any theory about deep learning, right? Pretty much everybody is like, okay, this is over-parameterized. It shouldn't generalize, but it does. And then I remember my fellow information theorists just writing it off as a heuristic. And I'm like, no, this is working. Clearly something is happening here. Right. So that's now a good problem to have. It's like, okay, we don't have theory that explains what's happening. And then you start thinking about it and then develop the theory. And then the theory took years to materialize. Then we got some information theoretic bounds that showed that, okay, generalization can happen. We got some other theory around double descent, obviously. So that was also older. But then theory came and followed along. And I think now we're doing a lot of empirical work, but then the theory is probably generally a little bit lagging behind. But I think that theory is going to also inform our practical explorations in the future.
Yeah, I don't know. I must say that like it feels to me a bit hacky in the sense that like so you have something that works, and then you have some so then you develop some theory, but then it looks that like you will change it and it doesn't really matter, right? Like you can get like 0.5% here, there, or there, but to use totally different tools. So it's not clear like what is the why we have this theory and like why we work so hard to develop it if like it doesn't say anything and it doesn't really capture, the real secrets, if you want, of deep learning.
I do agree with you in the sense that, yes, sometimes the theory doesn't materialize and have practical impact. Sometimes it helps us to get better insights on what's going to work and what's not going to work. So eventually, I think that's why I like doing theory over on the weekends, is kind of keeps getting me some insights about like what's happening and so on. And I'm not interested in theory that's mechanical. I'm interested in theory that reveals insights. And it's hard. It's really hard. Like I remember when I first got into language modeling back in 2019, I was thinking about it and I'm like, okay, we are throwing a bunch of data with a supervised fine-tuning loss, and then we're training this transformer model. Like, what kind of theory am I going to do in this space? It's like there's nothing I can do. It's like I just need to train these models. And it took some time to realize that there are areas where you can start to theoretically analyze and like maybe change the losses, etc., etc. But that takes a long time, and it all comes from distilling actual problems from the practical point of view. It's like, okay, in practice we have this problem, and then you're like, oh, now I can actually go and analyze this. And then it becomes an interesting theoretical nugget.
Yeah. By the way, what do you think about all the mechanistic interpretability works?
So I think it's interesting. I don't have a lot of opinion about the mechanistic interpretability works. Because so at some level, I'm not sure if you're going to ever understand these complex LLMs. But on the other end, we can see that they can offer valuable, basically, ways of improving the model, sometimes in terms of safety. If you think about it, the circuit breakers work around safety is also kind of is white box access, in the sense that you can think of it as mechanistic interpretability and so on. So I think it's an interesting direction to think about, and think about like what is happening in the network and whether or not there is interventions that we can do at the kind of node level within the network.
Yeah. I don't know. I must say that like most of the time it looks to me a bit hand wavy, for example, like sparse autoencoders and all these
Yeah.
works that like yeah you can even get some information theoretic arguments about right low dimensional spaces and things like that and why it works and why it's meaningful, but again I think it's very hand wavy and you look what you like, you get what you look for, right? And when you will try it in just very like a different scenario or different settings, like the conclusion will be totally different. So yeah, I
I,
anyway.
I look at them as tools that may be useful in some contexts.
And so do you think theory can get us like better models?
I hope so. As theorists, I think that's our hope. Now, and I think there are a lot of theoretical primitives in the current models. So the general, even the probabilistic nature of language modeling is coming from Shannon's paper. So I think theory has already had a huge impact on where we are today, and I'm hoping that it will continue to pay dividends.
Yeah, I agree. I think like there are areas that are still underexplored and we can use again, I don't think we can use like full theory, right? Like to derive the actual methods, but we can get and use insight and inspiration from theory about how the things are work and where we want to take them from here.
Yeah, I totally agree.
Okay, I think yeah, that's it. Do you have something that you want to add? Some plugin that you want to advertise?
No, I think I will maybe end with just asking everyone to try to go deeper in their research and try to understand things in a more deeper fashion than just do a very surface level 3% improvement and getting a paper out. I think we are all going to be better off as a community if people do that.
Great advice. I totally agree. Ellen, do you have something to add?
No, just we need more people doing proper good theory and spotting the bad stuff, because I think my over optimistic assessment of research is probably based on me not working so much in theory at all. So yeah, it's always a pleasure to have talented researchers. And I guess before, aren't you pretty big on LinkedIn as well? I swear I see your posts quite a bit.
You do. Yeah, I cross post between LinkedIn and
Yeah, yeah, yeah.
But
Well,
I think Twitter is a great platform to say what I think.
yeah, I think yeah. So I learn a lot from Twitter. I think like to Twitter interactions, reading other people's opinions. I think it's especially I try to engage with it on my weekends. The weekdays generally pass by, but the weekends I try to go look for papers, look for what happened and opinions, and I find it very useful.
Yeah, I agree. Okay, so yeah, thank you so much that you came to our podcast and hope that you enjoy it.
Yeah, thanks for having me, and it was a very exciting conversation. I really enjoyed it. Thank you.
Thank you so much. Bye, everyone.
Thank you.